Okay, let's start with discrete valued random variables. So these are random events that can take only a finite number of values. Can somebody give an example of a random event that takes a finite number of values? Anybody?
Coin flip.
Coin flip, there's a good example. Coin flip. That can be either head or tail. Die roll. There's another one that can take 6 values. Okay, so discrete valued random variables, they are characterized by probability. A probability function, sometimes called a probability mass function. So e.g., coin flip. Let's let 0 equal heads and 1 equal tails. So we will have this function, let's call it P. Let's let x represent the value of the coin flip, either 0 or 1. So P of x is the probability mass function. And what it will be, if it's a fair coin, then P of 0, the probability of the event 0, which is heads, is 1/2. Probability of the event 1, which is tails, is 1/2. And the interpretation, you should remember, is that that means heads occurs half the time, tails occurs half the time, usually. Okay. Let's talk about independent events. Excuse me, let me back up a bit. I can have joint probability mass functions. That's like 2 coins, x and y. So in that case, I have a joint function between x and y that gives me the probability of both of those events happening at the same time. Not necessarily at the same time. That might be misleading. Basically, it's both events happen together. What's the probability of these events happening together? So they could be x and y could be flips of the same coin, just separated in time. So you could say, what's the probability that if I flip it now, it's heads, and later on, if I flip it, it's still heads? So that would be just a function of these 2 variables. So the interpretation would be P 0, 1 would be coin flip. X is heads. And coin flip y is tails. Okay, independent events. Have the following property. P of x and y can be factored into P of x times P of y. So, e.g., coin flips are independent. Why is that? Well, pxy is equal to, okay, for x equals 0, 0, 0, 1, 1, 0, 1, 1. If they're fair coins, that's 1/4 in all cases. So a quarter of the time, those sequences will occur. P of x times P of y is equal to, well, if they're fair coins, and this is 1/2 always, that's 1/2 always. So for all 4 possibilities, we have 1/2 times 1/2, 1/4, and so on. So since pxy can be factored like this, those events are independent. The interpretation there is that one coin flip, if I flip the coin, if the x coin flip doesn't do anything or tell you anything about the y coin flip, they're not dependent, they don't depend on each other in any way. Okay, so the interpretation of the joint probability mass function is these events occur together. In other words, it's sort of like event A and event B. There's something else called union event of events, which is like event X or event Y. And the way in which we calculate this is, for instance, probability x equals 0, x equals 1, or y equals 1 is equal to the probability of x equals 1 plus probability of y equals 1 minus the probability of x equals 1 and y equals 1. So when you first learned probability, you should have learned this rule, and you subtract this out because within adding up these two probabilities, if you can show this with a Venn diagram, adding up these two probabilities, basically you're counting this event twice, so you have to subtract it out. Which leads me to discuss mutually exclusive events. So x and y are mutually exclusive if probability of x is greater than 0, probability of y is greater than 0, and the probability of x and y is equal to 0. So in other words, even though x can happen on its own, y can happen on its own. So the probability equal to 0, the interpretation of that is that that event cannot happen. So x can happen on its own, y can happen on its own, x and y cannot happen. So in other words, those two events can't happen together. So one way to interpret that, what's the probability of heads? 1/2. What's the probability of tails? Also 1/2. What's the probability of having heads and tails at the same time on one coin? 0. So that event, it's impossible to have heads and tails at the same time, so that event is mutually